India successfully test-fires hypersonic missile carrier. With this, India became the fourth country to achieve the feat. After this successful test of the Hypersonic Technology Demonstrator Vehicle, HSTDV, India will be making its first hypersonic missile in the next 5 years. After the US, China, and Russia, India is the fourth country in the world to develop and test the technology that will pave the way for missiles, which will travel at 6 times the speed of sound. With this mission, the Defense Research and Development Organization, DRDO, said it has demonstrated capabilities for highly complex technology that will serve as the building block for next-generation hypersonic vehicles in partnership with the industry. The Hypersonic Technology Demonstrator Vehicle used the indigenously developed Scramjet propulsion system. And, with this success, all critical technologies are now established to progress to the next phase. Sources in the defense and security establishment said the test was done from APJ, Abdul Kalam Testing Range, in Odisha's Balasore. The vehicle used the Agni missile booster. The DRDO statement said the cruise vehicle was launched using a proven solid rocket motor, which took it to an altitude of 30 kilometers, where the aerodynamic heat shields were separated at hypersonic Mach number. The cruise vehicle separated from the launch vehicle, and the air intake opened as planned. Defense sources said the hypersonic combustion sustained, and the cruise vehicle continued on its desired flight path at a velocity of 6 times the speed of sound, which is nearly 2 kilometers, for more than 20 seconds. The critical events, like fuel injection and auto-ignition of Scramjet, demonstrated technological maturity, adding the Scramjet engine performed in a textbook manner. The parameters of launch and cruise vehicle, including the Scramjet engine, were monitored by multiple tracking radars, electro-optical systems, and telemetry stations. The Scramjet engine worked at high dynamic pressure and at very high temperature. Ship was also deployed in the Bay of Bengal to monitor the performance during the cruise phase of hypersonic vehicles. All the performance parameters have indicated a resounding success of the mission. With this successful demonstration, many critical technologies, such as aerodynamic configuration for hypersonic maneuvers, use of Scramjet propulsion for ignition and sustained combustion at hypersonic flow, thermostructural characterization of high-temperature materials, separation mechanism at hypersonic velocities, among others, was successfully tested. Hypersonic missiles can travel at speeds faster than Mach 5, 5 times the speed of sound, or 3,800 miles per hour, much faster than other ballistic and cruise missiles. They are highly maneuverable and do not follow a predictable arc as they travel. They can deliver conventional or nuclear payloads within minutes. The DRDO last June also tested the futuristic missile test. However, the test did not meet all the parameters. India, of course, still has to achieve sustained Scramjet-powered hypersonic flight for a few minutes, which has been demonstrated by the US, Russia, and China. The Indian Armed Forces already have the ramjet-powered BrahMos supersonic cruise missiles, which fly at Mach 2.8 speed, developed jointly with Russia. Their strike range is being enhanced from the original 290 kilometers to well over 400 kilometers now. A Scramjet engine is an improvement over the ramjet engine, because the former operates efficiently at hypersonic speeds and allows supersonic combustion. Ramjets, in contrast, operate well at supersonic speeds, around Mach 3, but their efficiency drops at hypersonic speeds.